Here we're going to have a look at 2019, question 9, part B. So this might be a little bit of a weird looking question, but it's actually quite a nice one. So we basically have a little object, funky looking shape, doesn't really matter if it's funky looking shape, floating in two different liquids. And we see this from time to time. Okay, we have a top liquid here. It doesn't tell us, so I'm going to call it liquid 1, and a bottom liquid, liquid 2. And we need to find the fraction of the object floating in the bottom here. Now, before we go any further, I'm going to grab a little spare sheet and just have a quick peek at how we might represent this, because there are two different ways to do it. Pros and cons to each one, but for this kind of question, one is much easier. So there's our liquid, little object, and the two like before. Liquid 1, liquid 2. And we just draw a second version of it here, because nice neat diagrams, easier to work off. And there we have it. Liquid 1, liquid 2. Okay, so if we look at the fraction here, all right, we can divide this up. One way to do it is V1 and V2. Okay, well, the total volume is V1 plus V2. So if I was asked to find the fraction in the upper liquid, all right, that fraction there in liquid 1, which is of course the top one, 1 and 2, well, that equals V1 over the total, V1 plus V2. All right, option A. Option B is to bring a little bit of algebra into it, and we can say that this is KV, okay, where K is basically between 0 and 1, okay, so it's a fraction of the total, and that means the bottom, of course, is 1 minus KV. So the total volume is KV plus 1 minus KV. And if we work that out, that'll just become V. Now in this case, the fraction in liquid 1 is just K. Now, if we compare the two of these, you can see that this one has two different variables, okay, two unknowns floating around here. And we can solve them, and there's a relationship between them, but we often don't know the total volume, so it gets kind of messy. Or this one is much more straightforward mathematically. So this option here is usually a much easier way to go at these questions. Sometimes the marking scheme, you'll see them do this one, but the algebra is twice as hard. So let's come back to our question, and we're going to go with it this way. Well, now let's label this up carefully so we know what we're doing. I would call the section KV the one we need to do. So let's just pause and look at it. We are looking for in the upper liquid. So this guy is KV, which makes this 1 minus KV. All right, we're also given densities. This one is rho and this one is 2 rho. So write them in just so we know they're there. And the nice thing is we know what we're looking for in this question. So overall, the basic idea here is that the weight of the object is going to be equal from the buoyancy force in the first one plus the buoyancy force in the second liquid. All right, that's not so bad. Well, let's find the weight. The weight is V rho G. That's my general equation for weight. So in our case, weight is V, it's total volume, rho, and we're actually given that in the question. That is a D and G. So there we are. What about buoyancy? Well, buoyancy is V rho G again. There we are, just little boxes for our formula, and V is the fraction in the liquid. It's not always fully immersed. So in our case then, for B1, the liquid in 1, well, the fraction is KV. All right, the density is rho, and gravity is gravity. And for B2, well, the fraction is 1 minus KV. The density is 2 rho. Careful, that's a nice easy one to miss. Put it in brackets, keep it neat. And G. So now we have all our bits lined up. I'm going to take this equation and pop it in together. So what we have is V dg equals KV rho G and 1 minus K V 2 rho. And actually, one of the reasons I put the brackets around them there, even though it does seem kind of tedious, is it sort of reminds me to pause and not forget the 2, which would be easy. Now, I wrote that nice and big because I could see some cancellations coming up, which is great news. So let's lose our V's first. Nice clean little line. Don't scribble them out so they're impossible to read. You want someone to be able to see where you're going and you to see where you're going if you had to go back in it. And we can also lose our G's. They can go out there. Now, given that I've knocked 2 terms out, I'm going to take a little moment and just write that equation out again so I know where I'm going. K rho 1 minus K 2 rho. Okay, now I can see what's happening. Let's multiply this guy out, because I want to find K, so I need to separate that out. Plus 2 rho minus 2K rho. All right, those two are going to come together. And we have this. So now it's just a case of a little bit of rearrangement. Let's put the K rho on this side. So that is K rho. And we bring the D over here. 2 rho minus D. A little pause. Let's just check our solution. And we are on the right track because I have a 2 rho minus D. It's 2 rho. A little bit tidier. And that, of course, means dividing both sides by rho. 2 rho minus D all over rho. And there's our answer. QED. Lovely little neat part 2.